So what we're going to see here is that we've got, what kind of prism is this? Good, triangular prism. And what kind of pyramid is this? And you'll notice that actually they've got the same size base. And if I turn it this way, you can see that they've got the same size height. So which is bigger? You guys agree the prism is bigger than the pyramid? Okay, how many times bigger? We're talking about volume now. So if I were to, for instance, fill up this 2 times, that seemed like a good guess, huh? So if I were to fill up this pyramid and then dump it inside there, I think it would take 2 to fill it? Maybe 3? Maybe 3.141592? No, that's circles. Let's see. So I'm going to fill this up with 1. What do you think? Looks like 3, maybe 4. 3.5, 4, 27. Square root of pi. So here comes number 2. Okay. Looks like 3, doesn't it? You guys think I'm going to spill it out, don't you? It's even got that cool meniscus going on there. Can you see it? It's like bubbly on top. If I blow on it. Now the real challenge. Not a drop spilled. All right. So what we see is that the volume of a pyramid is 1/3 the volume of the corresponding prism. So in other words, whereas we've been using before, volume is capital B times H, now we just got to stick a 1/3 in front of it. Otherwise, it's the exact same process. So we're going to put a big B up here. We're going to put an H up here. And the volume is equal to 1/3 of B times H. So what do we put in for the B? Good. This is a rectangular base. When we find the area of a rectangle, it's length times width. So we'd get 10 times 11 is 110. And what does the height mean now? What's that H refer to? Excellent. Perpendicular to the base from the center point up to the apex of the pyramid. And what we can see here is that's going to be 16 units. So our volume is going to be 1/3 times 110 times 16, which gives us approximately 586.67. And what kind of units can we expect here? Very good. Inches cubed, because this is a volume measurement. Any questions on number 1? I don't think it's worth going through number 2 right now. That's one you can do yourselves. Let's take a look at number 3. What makes that one different? Good. You're missing the height. So draw it in. give yourself a line going from the apex straight down to the center of that base and make it perpendicular. That's what you want. That's your height. But in order for us to find out how long that height is, we're going to need to do some little creation. See, I've got kind of a half cross section here of a triangle. It's going to be a right triangle. How long is this base, do you think, of the triangle? Good. Half of this length all the way across. So that's 7. I've got h, a hypotenuse of 25. So I can use Pythagorean theorem. 7 squared plus h squared equals 25 squared. 49 plus h squared equals 625. H squared is 576, so h is 24. Now we'll fill in our B, H, and V. So to find my B, that's going to be this square base. The way I find the area of a square is 14 times 14, which is 196. What's my H? 24. Good. We found it using the Pythagorean theorem, which means my volume will be 1/3 196 times 24, which is 1,568 watts. Good. Feet cubed. How does number 4 change things? Triangular base. Does it change the setup? Do we still say B equals H equals V equals? We do. So what's the only thing that changes? Yeah, what this is. If you're finding the base area or the area of a base that's a triangle, what's our formula for that? 1/2 base times height. And this messes with people. The fact that I've got a B for base here, and I've got a big B that I keep saying base for here, but this is the area of a base, whereas this is the base of a two-dimensional triangle I'm trying to find the area of. So what should I use for my B here? Again, for this whole big B, I really want to just be focused on the yellow. I really want to look at just this. Yeah, I really want to look at just this triangle here and say, if that were my base, then I could find something that's perpendicular to it. And that's the trick, is I need these two to be perpendicular. So I could say that my base is the 12. And what is perpendicular to that? Good, 7.5. This gives me an overall base size of 45 units. And now I can get out of the yellow. When I start talking about this red H, I'm talking about the three-dimensional figure. What's the height of the three-dimensional figure? 10. So 1/3 of 45 is 15 times 10, 150 millimeters cubed, because it's volume. Now, if we look down to number 6, what do we notice? Again, we're going to be challenged with finding the area of the base. I hate to repeat myself, but it's all about the base. So what I'd like to ask is that we step off to the side for a second and consider the equilateral triangle. Let's say that, for example, I tell you that this side length is 12, and this side length is 12, and this side length is 12. Would you be able to find the area of this triangle? Now, as I said, we're just about done with geometry. Today, we're learning volume of pyramids, and we're learning surface area and volume of spheres, and we're done. So this problem is kind of a nice culminating problem for the entire year, to find the area of this shape. What's missing to be able to find the area of this? Because we know that the area of a triangle is 1/2 what times what? Base times height. And what has to be the thing tying the base and the height together? They got to be perpendicular to each other. So are you guys okay with us calling this side of 12 the base? I mean, they're all kind of the same, aren't they? I could like turn the paper around and I could use a different 12, but they're all kind of the same. But in order for me to find the height, it's not in this picture. So I need to draw it in. That's what I need my height to be. Geometry is really a science that describes why things are true. How do you know something is true? I want to use that concept to explain what the area of this is. We should be able to derive the formula for this kind of triangle. Sure, we know that the area of a triangle in general is 1/2 base times height, but how can I find this height now? Not yet, hold on. Pythagorean theorem? Well, if we had Pythagorean theorem, that only works if we've got 2 sides and we're trying to find a third. So if we knew this part here, do you guys agree we could find this using Pythagorean theorem? Good. So we've got a process to get there, but we're missing what this part is. It's 6. And here comes the real crux of geometry. Why? Okay. Surely you guys have heard something called fake news, right? The whole trick to you guys being good consumers, both politically and retail and scientifically and socially and everything, is that when somebody makes a claim, you should ask why. So Joe just said that because it's got a right angle, it's split in half. He said it very persuasively. But is it right? Or is it fake news? So let me ask a question. Could I draw a different triangle, demonstrate an altitude which is perpendicular to the base, in other words, making that right angle, and yet not splitting it in half? So therefore, the justification that Joe gave us that we all looked at and nodded to isn't sufficient.
Well, we know that a triangle is half of a square.
A triangle is half of a square. This is not half of a square.
It's an equilateral.
Yes, but a square doesn't come from. In fact, if this were aread, right, if we found the area of this, it won't be half of a 12 by 12 square. we know that this height is 12. This height can't be 12. The hypotenuse is larger. Stick with me here, guys. This is like the culminating moment of geometry right here. How do we define, how do we know with certainty how big that side is right there? Now, some of you may have learned a rule that I taught you, right? For instance, I might have said that any isosceles triangle, when you drop an altitude, also bisects the base. You might remember that. But why? Did you just trust me at my word? Oh no. What else have I misled you on? So let me try this. We've spent a ton of time this year looking at right triangles, have we not? But we've spent even more looking at two triangles and deciding if they are congruent. Are these two triangles congruent? Why? Because they're both 30, 60, 90? Why? Okay. Half of an equilateral triangle. It sounds like you're building in an assumption there, though, right? I'm trying to justify that this does split it in half. And you're saying it's true because it's true. And I know I'm being ornery here and pushing you guys. Why are these two triangles congruent? SSA. Okay, I love where you're going with that. You're saying that we've got these theorems, SAS, SSS, ASA, AAS, and RHL. And you're saying that if we use one of those, we can prove the triangles are congruent. The one you just gave me is SSA. Or is that bass backwards? Has ever heard that phrase? Because we would normally write this the other way, wouldn't we? And when we see that, don't we all react like, ooh, you can't say that in math class. This is one of the ones that doesn't prove triangles are congruent. So you're right, Emily, that is the relationship we've got. Please tell me what you got as the sides and the angle. Where'd you get those parts from?
12 is congruent.
Right?
And then there's one reflexive side.
Good, the center thing is reflexive, excellent. They both have a right angle. So she totally claimed it correctly, right? It's an ASS scenario, which doesn't work, asterisk, unless asterisk, Ellery.
Well, could it be SAS because that side is reflexive and then you have this 12 and then you know that it bisects that 60 so that they're both 30.
But we don't know it bisects that 60 yet. That's exactly where we're trying to get. If we knew it bisected the 60, then you're right. We could say side angle, side, side angle, side. And since these two sides are the same, these two angles are the same, therefore these two base parts would have to be the same. But we don't have that yet. We don't know that that 30-degree angle has been created. We're still stuck up here. Do any of these prove these two triangles are congruent? Does ASS work? Sometimes, always, or never? Never. Sometimes. When does ASS work? Yes, when it's actually RHL. If I say that these are right angles and the hypotenuse and this leg, it is an ASS scenario, but it's not just any old angle, it's a right angle. So now with RHL, we can say these two triangles are congruent. So what? Excellent. CP, CTC says that means that any corresponding parts must be congruent. So now these two are 30-degree angles, these two are 60-degree angles, and if this was 12, these parts must be 6. Now, where were we going again? We were still trying to find this height. How am I going to find the height given what I now know? Okay. What would you set up as your Pythagorean theorem? Six squared plus h squared equals 12 squared, right?
Oh, sorry, I was looking at the actual problem.
I know. I'm going to make you do this one first, though. So h squared is equal to 108. So h is equal to square root of 108, which is 6 times 6 times 3. So h is 6 root 3. This might ring some bells. Someone said 3690 triangle. Was that Nick or was that Joe? I don't remember. So if this is 6 and this is 12, this one has to be 6 root 3 because it's a 30, 60, 90 triangle. So if I want to find the area, it's 1/2 of the base 12 times 6 root 3. Half of 12 is 6 times 6 is 36 root 3. That's my area of this whole triangle. Did you follow? Let's see. Please find for me the value of this, the area of this triangle, 8, 8, and 8. Don't say it out loud. When you find it, use your calculator to get a decimal approximation, and it will be one of those 5 answers I've put up there as multiple choice. I want everyone to please find an answer. And if yours isn't one of the A, B, C, D, or E choices up there, look for a mistake because you've definitely made a mistake. I'm telling you the answer is up there. Anyone need more time? Okay, I'm going to ask for a choral response here. On the count of 3, you're all going to say a letter, A or B or C or D or E, that corresponds to your solution. And I want to say it loud. I don't want little whispers. I want Mr. Mystery next door to hear. He's in there. He knows we've done this 3 times today, and he wants to see which class is clearest, not loudest, clearest. Count of 3. Give me a letter. 1, 2, 3. Okay, so if this side is 8 and we drop the altitude, how does this thing split? How big is this? 4, and that's 4, which means how long is this? This is 4. This is twice 4. So this must be thank you, 4 root 3, which means the area of this triangle is 1/2 base times height, which is 1/2 the whole original base, 8, times this height is 4 root 3. So half of 8 is 4. So 4 times 4 root 3, 16 root 3. I mean, I could even just go with that. Since root 3 is less than root 4, root 3 has to be less than 2. 16 times 2 would be 32, and all these answers are bigger than that. So this is the only possible answer. E is the correct choice. What if I gave you another one? What if I asked you to find 40, 40, and 40? How long would this height be? No.
Or sorry, 20 root 3.
Right. These are 20, which makes this height 20 root 3. What if I gave you that this was 14 and 14? This would be 7 root 3. Okay. Please take that knowledge and figure out problem number 6 now. Find the volume of this pyramid with an equilateral triangle base. And feel free to draw the triangle over here if you need a little more space to get the base. So if I draw this altitude, how tall is it? Don't say it if you've already shouted out a prior right answer. How much is this base split into? 5 and 5. And if you need to do the whole Pythagorean theorem, you can do that. 5 squared plus x squared equals 10 squared. But ideally, you're remembering that this is now a 30, 60, 90 triangle. And if the side opposite 30 is 5, and the hypotenuse is 2 times 5, this altitude would be what times 5? Remembering this? If this is A, this is 2A, what's this? A square root of 3. So if this is 5 and this is 2 times 5, this would be 5 root 3. So my base, the area of my base would be 1/2 10 times 5 root 3. Half of 10 is 5. 5 times 5 root 3 is 25 root 3. What's my height in this case? Good, 16, which means my volume is 1/3 of 25 root 3 times 16, which comes out to about 230.94 watts, centimeters cubed. Please give me some feedback. 5, I've got this now. I can find the volume of pyramids. 3, it's starting to make sense, but some of the bases are hard, and I'm going to have to work on my 2-dimensional area knowledge. 1. I'm still struggling. I don't get the point. Good. All right. If we flip this page over to page 2, what you'll see is we're now going to work with cones. And sure, there's a new formula for this, but do we have to use a new formula, or can we just do exactly what we did before? Yeah, because what is pi r squared? It's the area of a base when it's a circle. So we can still do 1/3 area of the base times the height. So let's do number 1 together. What's my B? What's my H? Which lets me calculate, 1/3, my volume. How do I find the base area for this particular base? Pi times r squared, which in this case would be pi times 9 squared, which is 81 pi. What's our height? Good. From the center of the base, perpendicular up to the tip, is 17. So my volume is 1/3 of 81 pi times 17, which gives me 459 pi, or approximately 1,441.99 watts. Good. Any questions on finding volumes of pyramids or cones? Okay, last 2 pieces for the day, for the semester, and for the year. We're going to talk about spheres. And before we talk about spheres, we've got to get some parts for a common vocabulary. What do you call that point right there in the middle? The center. And if I were to measure from that distance, from that center, straight out to some point on the sphere, what do we call that? Radius. And if I were to go from some point on the sphere into the center through that center point, continuing on to another point on the sphere, what do we call that? Diameter. Nothing new so far, is it? But here's what's cool. This is actually a 3-dimensional object. And because we jump up 1 dimension, there's additional opportunities. In a circle, which is a 2-dimensional object, I can go from one side of the circle to another side through the center with a 1-dimensional object. I can slice through a 2-dimensional with a 1-dimensional. But since this thing is 3 dimensions, not only can I slice through it with a 1-dimensional diameter, but can't I also slice through it with a 2-dimensional circle? If I make a cross section of this sphere, if I cut through this sphere like a knife through a melon ball, what I produce is a circle. And it turns out this is the biggest circle that can be made in this sphere. If I cut not through the center point, I'll make a smaller circle. So this is called the great circle of the sphere. And it actually does split that sphere into 2 hemispheres. Like semicircle, this is a hemisphere.
Why is it not just the circumference?
Well, because circumference would be a linear measurement around the outside. It's a numerical value. This is an object, right? So difference between congruence and equality, kind of. All right. There are 2 formulas we're going to be working with today on spheres. Please be quiet, gents. we're going to be working with the volume formula and the surface area formula. And the mistake, hey guys, please stop. The mistake most people make is they confuse which one goes with which. I find it easiest to remember that if we're doing volume, is that a cubic units or a square units? Cubic. Therefore, it's going to be a pi r cubed. And because I put a 3 there, I'm going to put an extra 3 on the bottom. The formula for volume is 4/3 pi r cubed. Whereas if you look down at number 3 here, the surface area, is that an area or a volume measurement? Area, which means it's going to be a pi r squared. It's an area measurement. So there's no 3, it's just 4 pi r squared. And then it's just plugging it in. So in this case, what would be my r?
7.
So then I'll just plug it in and go 4 times pi times 7 cubed over 3, which simplifies to 1,372 pi over 3. And then if I plug that into the great calculator, I get 1,436.76 watts.
Inches cubed.
Good. Inches cubed. Joe, you were saying that you took a practice SAT this morning in a different class.
Yep.
And that they asked for the volume of a pyramid.
Yep.
Just hours before you learned it, which is super frustrating. Honestly, I always thought in the SATs, they usually give you the formulas.
I had no idea. I just did not look for it.
Yeah, you wouldn't have known to look for it. But honestly, you'll be able to find this formula often when you do this in SATs. Do you feel like the stuff, this unit in particular, it's pretty straightforward. If you have the formula, you just plug it in and go.
Yep.
Yeah, there are some twists. Sometimes you've got, for example, let's come down here and do number 4. There's a very, very slight twist in this. What's the twist? Excellent. Gives you the diameter instead of the radius. So what's our radius? 12. Question, Nick?
On our final for math, are the formulas going to be on the test, or
The final for math,
is there going to be a final test?
there is not.
Oh, okay. Then-
Here's what's going to happen. Today, you're going to finish up this packet. That is the last instruction on Unit 11, surface area and volume. Next class, I'll give you a review packet to do to make sure you understand how to apply all these things. We'll have a work session where you can see if you understand it. Another little mini review on Monday. And then Tuesday will be the unit test for Chapter 11. If you have done a good job this semester and are up to date on homework, and have taken the tests and asked questions about missed problems, and then retaken the tests and earned the scores that you're comfortable with, as soon as you finished your Chapter 11 test with a score you're happy with, you're done for the semester. You'll have 3 more block periods plus the finals week when I'm not going to require anything of you. You will rest on your laurels. You earned that grade. You get to keep that grade. There's a number of you in here that are not quite there yet. You're behind on a couple of tests. Maybe you've got some work you hadn't yet submitted and you want to get that in. You have until finals week to submit any work that you want to get turned in. And if you want to get any tests fixed up, those have to be done before the last day of finals for us, whatever day is our final exam period. And you have until then to get all this stuff turned in. There's no penalty for lates. But time is ticking for those of you that have been procrastinating. Now is the time to finish that up. Okay, let's just finish up this one problem. And then you got the rest of the period today. When you plug this in, you're going to end up with 576 pi, which comes out to approximately 1,809.56 watts. Excellent. This is area. So this is going to be millimeters squared. I know we've been doing a lot of volume, and so you're tempted to put cube, but make sure you pay attention to what you're using. And again, the pi r squared gives you a little symbol or an indicator that it's going to be square units. You have the rest of the period to work on this packet. 1 second.